One, two, three. Coastal populations and sea level change. The United States has one of the longest and most diverse coastlines in the world. It extends over 158 kilometers. Pause. One, two, three. Coastal populations and sea level change. The United States has one of the longest and most diverse coastlines in the world. It extends over 158,000 kilometers, over 95,000 miles, ranging in habitat type from tropical Pacific in American Samoa to the permafrost and usually ice-covered Arctic Sea in the northern Alaska area. Over half of the shoreline is found in Alaska. All of these ecosystems support a wide array of habitats, an enormously diverse array of species and communities, and are of fundamental importance to human and society well-being. Just a few of the ecological services provided by coastal habitats include flood control, water quality improvement by coastal wetlands, the tremendous productivity for fisheries and wildlife of wetlands, estuaries and the coastal ocean, the buffering effects of storms by barrier islands, and the vast biodiversity in coral reef ecosystems. Coastal areas are used for a wide range of overlapping and often competing uses, such as tourism, coastal development, and residential living, commercial and recreational fisheries, aquaculture, navigation, trade, national defense, and mineral resource extraction. No less importantly, coastal and marine ecosystems are intrinsically linked to planet biological and geochemical cycles, and consequently, the health and functioning of these ecosystems is crucially important to the health of the planet as a whole. Already, the majority of the population in the United States lives within 130 kilometers of the coast, and population growth in coastal areas is more rapid in the country as a whole. Currently, it is estimated that 53% of the total population of the United States lives in approximately 17% of the U.S. land area that is considered to be coastal. These coastal areas are becoming more and more crowded each year, by far surpassing the national population increase over the past 40 years. In 1960, there was an average of 72 people per square kilometer of coastline. By 1994, this had increased to 105 people per square kilometer, and by 2025, this figure is expected to rise to 126 people per square kilometer. Coastal areas also include 19 of the 20 most populated counties in the country. 17 of the 20 fastest growing counties in the country, 16 of the 20 counties with the largest number of new housing units under construction, and 18 of the 20 leading counties in per capita income. The list of ongoing stresses to coastal environments is strong and growing. A committee established by the National Research Council to identify priorities for the coastal ecosystem science generated one short list of key threats to the integrity of coastal ecosystems. These include eutrophication, habitat modification, hydrologic and hydrodynamic disruption, exploitation of resources, toxic effects, and introduction of non-indigenous species, global climate change and variety, shore erosion and hazardous storms, pathogens and toxins affecting human health. As coastal populations increase, the vulnerability of a developed coastline to natural hazards is also expanding. The most recent numbers indicate that there are an estimated 276,000 households located in considered to be high hazard due to storm surge, an additional 2.4 million households located in floodplains adjacent to high-risk zones. Disaster losses are currently estimated at about $50 billion annually in the United States, compared to just under $4.5 billion in 1970. As much as 80% of these disasters were storms, hurricanes, and tornadoes, as opposed to geologically related disasters such as earthquakes and volcanoes. And most of these have their greatest impact on coastal communities. For example, in the last decade alone, Hurricane Hugo, Andrew, and George caused respectively an estimated 9 billion, 27 billion, and 5.9 billion in damages to coastal communities. Meteorologists and climatologists are constantly improving prediction capabilities, reducing the risk of death and injury to coastal populations through improved forecast and preparedness by coastal communities. However, the growing concentration of population and development in these coastal areas will ensure that future damages from hazards will continue to rise independent of ongoing and future climatic influences. So, what zone are you? This is a picture of the zones for Virginia Beach. Do you know what zone you live in? When a storm is approaching, emergency managers will determine which zones are at most risk, considering the intensity, the path, the speed, the tides, and other factors. Properties in Zone A are located at the most risk of flooding and storm surge. That's in the red zone there. Then Zone B properties, then Zone C, and lastly Zone D. While zones won't always be evacuated in that order or one at a time, the zone designations are based on storm surge, flooding, and meteorological data. When a storm approaches, emergency managers at the state and local level will work with local media and use social media and other tools to notify residents of impacted zones and what they should do. You just have to listen for your zone and the instructions that would follow. So I picked this because it is the area that we all live in, and it includes our school, and tremendous amount of us live in that red zone. Generally, sea level refers to the average water level over the course of a 20-year period, which is enough time for astronomic and most climatic fluctuations to run through their complete cycles. Sea level rise is not uniform across the globe. Coastal communities are affected by their local sea level rises, which reflects global sea level rise, changes in local land elevation, tides, and wind. In Louisiana, for example, local sea level is rising about 4 inches per decade because the land is sinking and the sea is rising. Many places along the United States coast have seen their local sea levels rise faster than the average global rate. As sea levels have risen, the number of tidal floods each year that causes minor impacts, often called nuisance floods, have increased in 5 to 10-fold since the 1960s, and in several coastal U.S. cities, even higher. Rates of increase are accelerating over 25 Atlantic and Gulf Coast cities. This includes Norfolk. So this is our current sea level as it is today. If we keep going as projected by scientists, this is what it would look like in 2035. And that's simply with a 0.6 meter rise, which is conservative. And if you notice that just about a couple miles inland of First Landing will go underwater. Some of the coastal areas along the Lynnhaven Bay will also go underwater. And then this would be at 2050, the projected levels. And this, again, is conservative level at 1.2 meters. And if you look carefully, well, the area I live in would be gone. First Landing Park would go all the way up to the back part of the oceanfront, and several communities would be underwater. There are significant regional components to sea level change. The term relative sea level rise refers to the change in the sea level compared with the land elevation at a particular location. As this figure shows, the rate of relative sea level change varies considerably along the U.S. coast, largely because of land movements caused by isostatic rebound subsidence, compaction, and settling. Subsidence, extraction of water and petroleum, and tectonic factors such as earthquakes. For example, within the U.S., portions of the Gulf Coast are experiencing a relative sea level rise of about 10 millimeters per year, or 1 meter per century, largely as a result of land sinking. Currently, portions of the Washington and Alaska coastlines are experiencing a relative sea level fall of up to 8 millimeters per year, or 80 centimeters, 30 inches per century. And this is a result of glacial rebound and tectonic uplift. Coastal erosion accelerates as sea level rises. Erosion decreases the value of coastal properties because it decreases the expected number of years away from the shoreline, as researchers and underwriters put it. Pause. 1, 2, 3. Coastal erosion accelerates as sea level rises. Erosion decreases the value of coastal properties. This is quite a loss to U.S. property value and it amounts to about $3 to $5 billion per year. Then there is the actual loss of property, including structures, which amounts to about $500 million per year. Eroding coastlines are also at greater risk of storm damage. Property damage from hurricanes along the eastern United States is estimated to average $5 billion per year, with the cost of 2004 alone estimated to be $21 billion. Such calculations rarely account for the long-term cost of flooding and erosion, damages to natural landforms or ecosystems, and the loss of recreation and tourism opportunities. Beach erosion threatens property near the shoreline, but it also profoundly influences a critical part of our coastal ecosystem, the marshes. Tidal marshes and estuaries and behind barrier islands are dominant habitat along the Atlantic coast of the United States, and they are particularly vulnerable to sea level rising.